Welcome to our very short lesson in physics. Today we will speak about physics of Aristotle. In his book entitled Physics, he wrote 2500 years ago that a body which moves straight on will move for infinity, will go straight on for infinity. Well, like in this experiment. Then, until another heavier body stays on its way, until it encounters another heavier body. Well, exactly this is correct. Well, the body is reflected, makes a collision and stops. Then we will wait until 17th century with Cartesius. Cartesius introduced the name of momentum. Momentum is not a very good name because it would be also a piece of time, but momentum in physics means that something is in a movement. In French, it was mouvement, movement. So, and Cartesius says that one body passes to another the quantity of movement that it loses. Again, one body passes to another one the same amount of movement that it loses. Let's make the collision. Yes, it happens exactly like this. The movement of this car is transferred to this one and this is stopped. Well, but the laws of mechanics by Cartesius were not quite perfect. We need to wait until Newton with his cradle. And this is a toy on almost on every desk in every office. We leave one ball and the last one is reflected. We make this collision that one body starts and another is reflected. Well, how to explain this? Let's start from an easier example, just two balls, and try to make a collision. I will launch the yellow one, and yes, it stops, and the red one is reflected, makes the collision and starts to move. Okay, so this is clear that one body transfers to another the movement. But why just one is reflected? Well, we can treat the other as a fixed body. Or better, the first one makes the collision with the second immediately with the third with the fourth, and the fifth is reflected. Then, if we want to launch two of them are reflected. If we launch three of them are reflected. To make the calculation, we need to enter into details of the collisions. We must consider both momentum and energy. Well, I have many other tick-tock is called this toy. I can make collisions just with the equal velocities, or I can make a circular collision. One hits another one, and it's even difficult to notice which moves, which is stopped. Well, it does not work so perfectly if one of them is broken, so the mass is smaller, and the collision is not exactly perfect. The perfect transfer of the movement is if they have equal masses. I have more toys like this. Well, but I'm not very practiced in playing with these funny toys. Let's make another experiment. The last one, you know already. We will make a collision of two balls with different masses. This is heavier, this is lighter. I launch them together, and the lighter goes up to the ceiling. It's reflected. Let's do it again. It gains the energy and it gains the momentum from the heavier one. But now check what is the height at which the green one should be reflected? Well, it should reflect on more or less this height. Let's do it together with two masses. Well, last one, another. We will do it again. Just a second. Yeah, yellow is green one is reflected on much lower height. So, coming back to Aristotle, he was right that in the collisions bodies lose energy. Cartesius was right, and Newton was right. So have a lot of fun with all collisions, but make them with toys, not in your life. Thank you very much.